The other day I had a question about motors. There was someone that sent a request in about motors, but before we get to that part, what I want to do is talk about basically what is a motor. Well, we know what motors look like. We know, because we have installed them, we've worked on them, we've checked them out and so on. But basically, what is in a motor? What do we have in the motor? So basically, when we think about it, we do have the motor casing like this. And of course, it's going to be mounted on something here. Inside here, we're going to have what they call a rotor. This rotor is going to be sitting in here like this. And then, of course, we have the shaft right here. Now, the other thing that we are going to have here is we're going to have the wires coming in. When we have these wires coming in, well, they're going to be basically making up the windings, and then they go back out. So you have power that comes in, power that goes back out, and we have the windings. So now we see basically three things. We see the casing, we see the windings, we see the rotor, and there's something else in there. There's something else. That's going to be the bearings. The bearings. That's basically all that we have inside of a motor. Those are the things that could actually basically go wrong. Well, let me ask you this. With a casing, what can go wrong with a casing? It's just the shell, so nothing really can go wrong with a casing. What can go wrong with the rotor? The rotor basically is just more or less a hunk of metal, because the hunk of metal is just going to sit there and it's going to spin, it's going to rotate. That's why it's called a rotor, because it rotates. So then we have the bearings. Now, from what I just said, nothing can really go wrong with the casing. Nothing really can go wrong with the rotor. The bearings, they're going to be holding up the rotor. And because they're holding the rotor up, sometimes the bearings get weak. When they get weak, then sometimes what happens is that they fall a little bit. Once they fall, this rotor starts to rub. As it rotates, it starts to rub on the stator. Because it's rubbing on the stator, you'll see marks on the rotor, but that's not something that went wrong with the rotor. That's something that went wrong with the bearings. Now, when we look at the motor, basically looking at it from the end, we're going to have the casing like this. Then we're going to have the windings around like this. Then we're going to have, like I said, the rotor. The rotor is going to be sitting inside here. It's going to have the shaft, and then we have the bearing. We have a bearing in the front, and we have a bearing in the back. These bearings make it easy so that this rotor can sit there and actually rotate. That's why they call it a rotor, so that it can rotate. And what I was saying was, once these bearings fail or they drop, then this rotor is going to drop and is going to hit the stator. But again, it's not a problem with a rotor, it's a problem with the bearings. Now, what else can go wrong with the bearings? Well, what happens is the grease on them, the lubricant that's inside, sometimes it wears out. We're supposed to lubricate the motors, and some of these bearings, you can't lubricate them. They come sealed. They're sealed bearings. Because they're sealed bearings, no lubricant is needed, and over time, the lubricant kind of wears out. Because of that, the bearing is not allowing the rotor to rotate like it's supposed to, and the motor has to work harder to rotate. Now, some engineer, somebody that knows what they're doing, they figure this out. They know at what speed this motor is going to be rotating and what the windings are supposed to be doing. But the windings, basically, they're going to be generating a magnetic field. They induce a magnetic field into the rotor. As they induce a magnetic field into the rotor, this rotor is going to induce one back into the windings, and it's going to start to rotate. Once it starts to rotate, then it creates what they call a counter-electromotive force. So it's this magnetic field that's fighting the electron flow in the windings. And that's what slows down basically the flow of electrons in there. And that's why when a motor starts up, if you think about it, you hook up a meter to it, an amp probe. When it starts up, the amperage increases and then it drops like this. So now this right here, that's what they call the inrush current. That's the inrush current. So here it draws this amperage. As the rotor rotates, the amperage drops, and then it stays steady like this. So this right here is what they call running load amps. Running load amps. So now we're drawing what they call running load amps, and that's normal. If these bearings start to go bad, they slow the rotor down. Once they slow the rotor down, it does not create as much of the counter-electromotive force, so now it allows more electrons to flow through. The more electrons you flow through, the higher the amperage is going to be. So now this, instead of being here, is going to be up here someplace, or maybe even up here someplace. Because of that, the amperage is going up. When the amperage goes up, two things increase. One is the strength of the magnetic field, and the other one is the amount of heat. So with this, in this example, what we're concerned about is the amount of heat. So as the amperage goes up, it heats up. Now when we look at the windings, you're not really looking at the wire. What you're looking at is the insulation that's on the wire. Now the wire is made out of copper. The insulation is made out of a lacquer. Now this lacquer is kind of like varnish, let's say. And if you ever did any woodworking, when you sand it, it gets hot and it gums up the sandpaper. Well, as the amperage increases, it heats up and it starts to melt. As it starts to melt, what happens is these connections will touch, and when they do, then we end up with a short. Now we end up tripping the breaker or maybe blowing a fuse. So we need to make sure that our motor is rotating at the proper speed. In this example, I've been using the bearings as to what is slowing it down. But what happens sometimes is on here, we'll have a pulley. And this pulley is going to be driving something else right here. And in between the two, what we have is a belt. Now this belt, if it's too tight, what's going to happen is going to slow this down. When it slows this down, this rotor is not rotating at the speed that the engineer designed it to rotate at. Because of that, you have less what they call counter-electromotive force, which means that you allow more electrons to flow through. When that happens, the amperage increases. When the amperage increases, the insulation melts, and we end up burning up the motor. That's why it's very important not to overload a motor, whether it's because your belt is too tight or because whatever you're driving, it's heavier than that motor is supposed to handle. If the bearings slow it down, that's going to slow the motor down again, and with all of these, the amperage goes up. So these are some of the very, very basics about motors and why we need to lubricate the bearings, why we should not have the belts too tight, why we should not overload a motor. Whether it's a motor that is driving a fan or a pulley or maybe a conveyor belt, even a compressor. If your compressor works too hard, it overheats the motor that's inside. Same principle. The motor overheats, we destroy, we burn up the motor. So again, these are some of the motor basics that I wanted to get across to you. There's a lot more to talk about because there are motors that work off of alternating current. There's some motors that work off direct current. There's some motors that work off of both alternating and direct current. It just depends on the application and what it is that we want to do. But on another video or maybe a webinar, we'll talk more about motors. My name is Julio, and please go ahead and follow me on Facebook. Go ahead and check out my YouTube webpage. Go to YouTube and make sure you subscribe. If you have any idea on motors, any idea on videos, whether it's about motors, compressors, or whatever, just send me a message and I'll see what I can do about getting those online. And that way I can help you guys have a library where you can look at these videos when you have a question about something. Again, my name is Julio, Aircon Academy, and I'll see you soon. Thank you.